So I think we're almost there to bring the third speaker on the stage. John, I see your smiling face there. Please, there you go. Oh my goodness. I have to, you can need to unmute yourself. By the way, for the last 2 hours, I've been really like anxious to always have to see the face of John smiling on me. So whatever I was saying, I was always measuring it to see like, okay, my God, John is listening to this. I should behave myself. So
Oh, please.
it's always there. So man, how are you doing?
I'm doing well. I'm doing well. Thanks for having me on here.
Absolutely. Which city are you dialing in from? Chattanooga?
I am in Chattanooga, Tennessee right now. Yep.
Awesome, awesome. So I think if people don't know about you, they're missing a lot in their lives. Do you want to tell people a little bit about you? Means you are, I think, just like every other speaker over here, you're doing so many things. As a foresight person, you're into shift. You're an educator. You're into branch. Uh,
Yeah.
how do you manage all those things?
Well, I do all of them poorly, so I think it works out. It's okay. No, it's yeah, it's a wild ride. So I started out my design career as an architect, and I went to school at Auburn University. Graduated from the Rural Studio. So if you don't know anything about the Rural Studio, please spend a few minutes and research that. It's a quite a humbling journey to design for those that didn't know that they deserved design, good design. Um, and then worked for a few years as an architect, and then went back to school for industrial design because I was blown away by what I learned at the Rural Studio, where I interacted with the client so emotionally, developing their space. And then I kind of lost that as you went into industry. It just wasn't the same, at least from my experience. So I felt that industrial design, one, changed the scale for me, but it also allowed me to co-create, I think, a lot more intimately with people. And so I went back to school for industrial design and then fell in love with teaching. And so I taught at Auburn for a little while, and then ultimately moved over to Savannah College of Art and Design. And I taught there for 10 years and helped to develop some of their UX and service, their industrial design program. They have one of the largest industrial design programs in the country. I think there are somewhere around 600 students now. So it's pretty large, pretty diverse. And while there, a few of my partners in crime there started up a camp called Shift, and that was to help add out of the class experiences where we would build empathy, emotional intelligence, all the things that are going to get you further in life than your hard skills. You know, the hard skills get you noticed, but seems like the emotional, the EQ will get you further and get into those leadership roles. And so we felt that there was a real need for that in higher education. And then most recently now, for the past a little over a year, I've been the Director of Communications and Marketing for Branch Technology. And I just started up the Advanced Concepts team, where we are now doing not architectural products, but DoD military kind of focused stuff using our advanced manufacturing technologies.
Wow, fantastic! And eventually we will jump into that and like to see you present about that kind of a story and narrative. But before that, for the audience, if you have not known or heard about Shift Design Camps, as John was saying, is an out of the class experience like no other. I have been privileged to be attending a few of them, and the experience that you collect, not just in the nature setting or learning from the other people in the cohort, not just the facilitators, but everybody between it's literally, I would say, life changing. And in the last 2 or 3 parts, I have changed my life with all those things. But before I will request you to share your slideshow and present us the branch elements. Now I know the secret to your youth-looking face. There is a aloe vera plant right behind you. I think
Yeah,
that's
so
what you
much.
use it to apply every night to your lovely face to get the shine on you.
We collect this. We have a bathtub full of it back there, and so I soak in it 17 minits a day is the key.
I like that. 17. I need
No more, no
I need to
less.
write
Yeah.
down 70 minutes a day, aloe
Yeah.
vera plants. And you already gave up. You said you have plants back there in the basement or the bathroom. Maybe they might be different plants then. Whatever works for you. I'm glad you did not mention the name of it on a public domain, but I'm assuming they're going to be aloe vera plants and herbs and tomatoes and
Of
cucumbers.
course, absolutely. We have a garden here.
So I'm really dying to see the elements
Sure.
when you say about mega 3D printing and branch technology. please take us on a journey to understand what it is and share some of your some of the work you are doing.
Yeah, yep. I'm gonna do a share my keynote and do that. Talk to
Yep,
me. Does
we
that
can
look
see it.
good?
Yep.
Good. Okay, so Branch Technology is a relatively young company. We're about 7 years old now, and we are in Chattanooga, Tennessee, specifically put in Chattanooga, Tennessee, because there's this incredible advanced manufacturing corridor that runs from northern Tennessee, part of the way from the Virginias down through Tennessee into northern Alabama. So Huntsville, Alabama is home to Rocket City. It's where we launched a lot of the rockets from. It's where a lot of the NASA technology is, where the Redstone Arsenal is. Oak Ridge National Labs is just north of us in Knoxville. That's also where the atomic bomb was created. It's where a lot of the advanced manufacturing technology is developed for the U.S. military and DARPA and stuff like that. And so we're literally right between those two cities. And so Branch was started out because someone was inspired by nature. So I was really taken back by what Doug was saying. So we are a team of engineers, designers, scientists, artists, and of course we have some sweet robots that work with us. And we were started by an architect, Platt Boyd, 15 years ago. He was a partner in a company, in an architecture firm, and he just got tired of dreaming for one thing and only being able to build another thing, right? So he was wishing he could do all this, but at the price point, he was only allowed to do the boxes. And he was totally inspired by nature and how can we embrace biomimicry to create. And so he really started prototyping with these. If you guys remember back on Kickstarter a long time ago, the 3D Doodler pins, he bought one of those and just started making things and trying to figure out how could we use advanced manufacturing to change the construction industry. And so they bought up a robot and started making stuff, right? And so they started developing their own hardware or their own software. And then after a few years of kind of playing in the garage, ended up moving to Chattanooga because of the the world's fastest internet's here. There's a huge entrepreneurial ecosystem here to help startups grow. And so it's a win-win for advanced manufacturing startup. And so now this is our factory. We have 40,000 square feet and we can fit 36 robots in that space. And we're currently at 12 robots. So we're growing and we can, as you can tell, we can print massive components. So these are large KUKA robots on tracks, and we can print volumes of 3,000 cubic feet in a single piece. So somewhere between like a 8 feet by 8 feet by 35 feet is roughly our volume, our envelope that we could build. It's pretty big. So I'm going to play this video. It's probably going to be, Zoom does a really bad job of translating video. So, but hopefully it's not too clunky. So what we do is we do something slightly different than normal FDM printing. We use cellular fabrication and do freeform printing. So our plastic actually solidifies in free space. And so that allows us to use 20 times less material to get the same exact volume that an FDM print would. It also means we can print a lot faster. And our parts are extremely lightweight and extremely strong. They have a 2,500 to 1 strength to weight ratio. So if you took a concrete block size of this matrix, and this matrix here is a carbon fiber polymer mixture, that concrete block would be able to hold up roughly 3,000 pounds. Then we could fill it with a material of the client's choice and get almost to 10,000 pounds compressive strength on that same block. So it's an incredible strength to weight ratio, and it's not monolithic 3D printing that most people think of, right? Our goal is to use 3D printing for what it's good for, democratizing the design, being lightweight, and being a trellis to hold other materials effectively. What's also great about our materials, I'll play that again so you guys can watch that again. What's great about our materials is we have 5 different materials in our material portfolio. Some of them are bioplastics, all of them are reusable or compostable. And so we could literally take this piece and reuse it 5 times with no degradation in any of the capabilities that are necessary for our work. And so then we would use a process to bring those parts back, refine the plastics and polymers, use them again, and use the powdered foam or concrete or rhino lining or something like that in another project. So the robots are only part of our process. We have a bunch of architects and engineers in-house. So we take that 3D model from a client, and we have a technology stack that we've created that we'll go through and computationally help us translate what the client wants and what the robot can create. And then we prefabricate, modularize all the parts and ship them to site, and then we put them together. So this is an example of like a concrete facade. But a lot of the stuff we do is these really beautiful outdoor pavilions. This was the 2017 world's largest 3D printed sculpture for Design Miami. And it actually did a really great job in lasting through, I believe, 2 different hurricanes, and had 3 different lives. So it lived here for a while, and then it moved on to Kenya as part of the UN headquarters down there. And I think another part, we split it into 2, and the other part is, I think, in Yale. So the parts are really lightweight and really strong. So this is in Chicago. Chicago has this beautiful open space, but they wanted to bring in lights. They wanted to change the scale of the space. And they also wanted to hydrate the space a little bit more. The humidity was a little off. So they wanted to bring in plants in a safe way. So that larger spanning object in the middle is 38 feet across. So the scale of these things are pretty massive. But it holds 30,000 pounds worth of lights, plants, speakers, things like that. So it's pretty cool. You can see how the plastic interacts directly with the metal substructure, holds all the water, routes it all through there. It's a beautiful amalgamation of all those little trades coming together. This is the 2018 largest printed structure, and this is in Nashville, Tennessee, right outside of the Microsoft HQ there. And so this is at the OneCity Pavilion. This has a great story to it. So the project almost failed because the whole thing was going to be made in metal, and there is no metal in this at all. It is all carbon fiber polymer. But they were trying to build it in metal, and ultimately couldn't make it happen because it was too expensive. So we ran all of our tests with parametric and generative on there and tried to come up with solutions, and came up. And so nature, right, came up with the answer for us through this form optimized solution. And then we would take that and divide it up into parts that align to our print envelopes and for shipping. So we always look for that bottleneck in the process and try to figure out the best part size for that. But we've been asked to make crazy looking meeting rooms for big headquarters. This band shell started out like this, and ultimately through the design process, we get to something like this. Nature loves climbing up on our stuff. So we have all these different organizations are asking us, can we use this as a true trellis? Obviously we could. This is a hotel here in Chattanooga that was very interested in us softening the outside of their building, adding these faceted designs. This is at the University of Tennessee in Knoxville. They have a drone program, I believe. And so this is a drone landing pad outside their building. And here at a hospital locally. So very lightweight, very strong. These projects have been out in the elements for years and doing quite well. So when you take that carbon fiber polymer matrix and you mix it with the other materials, right, then you start adding real true capabilities for changing the construction industry. And so this was a international design competition to come up with a house, and out of the something like 1,900 different entries, this was the winner that was chosen. And this is out of Chicago, a company called WATG came up with the solution. And so this is a 3,000 square foot home, and we have 100% printed it, and we have roughly 60% foamed it and milled it down. And so now we're working on logistics to the site and working through all that. So we actually work with SOM, the team that actually worked on the Burj Khalifa and all of their engineering FEA studies and stuff like that. That's the team we work with in developing this. And so it is a beautiful dance between the inside and outside. It's this incredible, candy shell that just envelops this internal space, but it's big. This is it inside. So we print all that stuff and we, compartmentalize it. One, to get it out of our factory. Two, how big can pieces get onto the roadway? And two, or three, and then you have to put it together on site. So what are some man-sized pieces so that you can move them around? But we can, with the wall thicknesses and the insulation values, we're getting roughly an R80 as an average on these walls. So the wall in your home probably has like a, I don't know, a 20-ish, maybe less. So we're getting an R80, 80, which is pretty incredible. So we're getting really, really good at creating a net zero home here. But we've got projects happening right now. So this is a credit union here in town. All these are concrete GFRC panels that have been 3D printed and then milled here in our facility. This is kind of doing some sculptures on the outside of some parking decks in Huntsville, Alabama. Pretty standard, architectural elements that are needed, but we're doing it in a much more efficient. There's a great story with it. These are really lightweight, but very durable. But we can also scan, like this is the topography of the moon. So this is with a project for NASA, where they really wanted to take the surface of the moon, right, and give it the ability to be touched by the kids that are coming into the building. So we literally scanned it and translate that into Rhino, and then turn that into parts that we can print and mill and ship it to the site. And I think what's great about this is then you start thinking about, well, what else can we do with that, right? So then we can scan mountains. We can start creating themed entertainment parks. These pieces can get quite large. This is in the factory now. This is a 24 by 7.5 foot tall rock wall that we scanned and have now brought it inside. And so we've been talking with companies that are very interested in this kind of stuff. So it can be quite large, or it can be quite small. You can imagine trying to cover up stuff on a site, any infrastructure that you want to hide, or a secret base, or if you're trying to hide a rocket launcher or something like that. You could have the really light things. These pop open, rocket launchers go out. I'm not saying anything more. But we've been developing some pretty cool educational content around that, because no one really knows how to use our technology to create these objects, because the way that we print is much different. So we've had to teach people how to do this. And so creating videos and guidebooks so that others can understand this. And so we've been helping, here with the Air Force, helping them understand how can they create products using our technology. Right, so most of what my team does with the advanced concepts team is help them figure out what can they do. They have these odd shaped parts. We need to protect them and move them and hide them. And so the things that I can show you are simple things like this, like how do you store stuff like this. And as the industrial designers in the group will, taking concepts and then really starting to refine them. What else can you do to add primary and tertiary functionalities to these things? It's a really awkward shaped object that they need to stack, and we've been prototyping these here in house. There's nothing really proprietary to see. It's just cool to see the process that we're going through in conjunction with the Air Force, just talking through that. And then once we start talking internally to our production team, they need to know what it is they're making and how they're going to go through and make it. But we have a totally digital production line, so we have a single source of truth, right? A lot of people call it the digital thread that takes the original product all the way to the end for QC. So like I was saying, we have some incredible strength to weight ratios. And so a lot of talks around lightweight structures, thinking drone bodies or wings or things like that, right? So the bottom left is a wrapped carbon fiber wing, or some type of fabric in the top left or something like that. I mean, these are just extremely lightweight. And so Branch actually did a really great job a few years ago with the NASA Habitat Challenge. We came in first place, and we developed a material that is 70% Martian regolith and 30% mission waste. And so we developed that with Foster and Partners, the architecture firm, and a company called Techmer, which is up in Knoxville, Nashville. And so that way you can get to either the moon or the Martian surface, and you can start to, suits and bags and bins that aren't needed anymore can be pelletized and then mixed in with the dirt on the soil of that planet or that space body, and mixed together to create the material that you're going to print with. And so that's what we printed here. We ended up calling it polyrock. And so we won the NASA Habitat Challenge with that material. We built this dome on site in that trailer that's in the back of that image there. So we did it on site. And so that proved that our technology was capable of working on the lunar surface or the Martian surface. And we've been in discussions with different companies through that. So you're probably very familiar with AI Space Factory. You can see their sexy cocoon images, renderings all over Pinterest and the web and stuff. So what happened was they actually took over our spot in that team. We backed out of continuing the conversation because we had other client-focused projects that we needed to work on. And so I think AI Space Factory was born out of that, and they kind of filled in that spot. And so they took our material and that team and kind of went to the end. And so just imagining where we could have been by harnessing the momentum that we had already started would have been really pretty incredible. So we're continuing that conversation with Space Force now, trying to figure out how do we use our technology in, whether that's, I guess it could be on the Martian surface, but it could just be in zero G, because we actually don't really need gravity for a lot of the stuff that we do, which is different than FDM, which requires that gravity to hold that down, which is a very, very different mechanism. So thinking through that a little bit more, we've been really focused on, our team's been focused on what does that look like. And so working with different museums on how do we start telling that story internally and start getting the next generation inspired about off-world architecture and construction. And so that's been a lot of my time the last few weeks, is really getting in there and understanding who those players are and how do we get more involved in that. So that's it. That's what I've been working on for the past few years at Branch, and it's been an exciting ride. And that's it.
Wow, John, are you lucky or what? I mean, that's a
Yeah,
great area to be in.
yeah, it's pretty cool. It's inspiring every day. Yeah.
It means, is there anything that seriously you cannot do? Because I think scale is always an issue when you are catching the bull by its horn.
I mean, I'm not the smartest person in the room there by any means. I'm really the dumbest one. It's an incredible group of people, and all I have to do is try to envision stuff, and they tell me, thumbs up, thumbs down, or give us a day or two. And so, it's I'm always impressed by the challenges that the team faces and overcomes.
So I think there are a couple of questions. I think one was from Pierre. I'm going to go with the second part of it. Then we'll come to the first part of it. Pierre asks, beyond architectural projects, do you also work on industrial and or consumer applications?
We do, and that's mainly what the advanced concept teams does. Yes, it's focused on mostly DoD.gov stuff, but the also is the fact that we're not doing architectural focused stuff. I'm trained as an architect. I'm not licensed as the architect, compared to the other team, which is focused on architecture and is licensed as architect. So big difference in their knowledge base. But you have to imagine our scale is huge. I mean, these are, I would say,
8 by 8 by 35. That's a huge scale.
These are the smallest things that they've ever printed, right? I mean, these like logistical parts, these risers, in a sense. These are the smallest things they've printed. Just because, I mean, I'm gonna do this real quick. I'm going to do this so that you guys can. I mean, right, so this is pretty lightweight, but I mean, even this is one of our smaller parts, just for me to show you kind of the stuff. So we do FDM, beautiful FDM, on the surface of this matrix.
That is beautiful. That is absolutely beautiful. And when it's so, like, I know you're a strong guy, but that happens to be.
I work out every day, really. So
you're the as such. But coming back to the genesis of this means connecting with our first speaker also means this is literally inspired from the bone cross section, right? Means you are putting in the strength through this complex nature inspired, nature informed lattice structures, and then filling it with foam for the lightweight and rigidity as such. So it's literally going from that micro section to
Yeah,
building mega scales.
but that's exactly how um, we all have our strength. The cells in our body are given their strength by not the cell walls, but the fluid in this in the material inside of that, right? So this is strong on its own, and it becomes 3 times stronger by the material that we choose to put into that, right? So we have material scientists that are examining the polymers that we use. We're changing up monthly the computational algorithms that we're using to create better and stronger matrices. And then the material that we're putting inside of this is constantly changing as we find new needs and capabilities to kind of complement the carbon fiber mixture that we have.
Yeah. So is that carbon fiber, the
This
one you're
is, yeah.
showing? Okay.
Yeah.
So I think you showed the children's hospital also. It was yellow, bluish, and green color. Can you also print in color?
We can. It's a longer lead time. And so one of the things that we choose to do is paint that. So we can go through and paint and match color match a lot better that way, actually.
And that means that's so many questions coming in also, and I also have questions. The one that you mentioned that you did an exhibition over here, and then you moved it to as a UNESCO a kind of a headquarters. Did you use the same thing and just move it over there, or did you print one there as such?
No, no, it was the same one. It was the
Same.
same one. Yeah. So this, let me go back to it. There's actually 2 of the domes. Um, 2 of these domes lived in Miami. There's 2 of these. You can see the one off in the distance back over here. And so one of them went to, they both lived through multiple hurricanes. One of them went to the UN, and then the other one went up to Yale.
So I know the answer would be yes, but if it stands a hurricane, it would stand the question I'm asking. You know me, if I see a structure like this, I'm just going to crawl on the top of it. Can it would take my weight, right?
It probably would. But it's if a truck hit it, it would break.
Yeah.
If you wanted to crawl on it, I think if you have experience rock climbing, you probably could do it. These handholds are finger size, right? So you're not gonna be able to just scale up at it very well.
No, I'm asking about trying to think about if you're trying to design a play structures. Means I did
Sure.
my background for my kids, but if people are going to do that as a part of their tree house, means I can design my own tree house, and eventually you can print it for me specifically for my backyard with the trees over there, and eventually a tree house. The main thing about that is never square in nature. So if we can build something with this and finally add it in the backyard, that will be an amazing business.
Yeah, and that's the thing is like once you scan the site, whatever that site is, right? You can take it into the program, and you can generate tons of solutions around just making sure that you are close or kind of estimating how the tree is going to grow over time, and you can build that in.
So and again, thanks for letting us know. And I know you can only show only so much or share so much, but as a business, as branch, do you also offer design services? Like if somebody has something to do, can you come in? Do you do scanning? Do you do this all the design services and then finally deliver the part? It's all the art to part kind of in business you're in.
Yeah, a lot of times the client will just say, "Hey, we have this space and we don't know what to put in it," or "Hey, we have this, we have the site. Can you guys be the creative agency to help us figure out what should go there?" And I think that's where a lot of our generative and parametric tools come into play, so that we can start ideating around what the client might want and doing a lot of different permutations of that before hitting print.
And I think the question is, can you also print on site? I think the answer means, I think the off world in Mars and Moons, you have to, but right now the business model is you still print there in Chattanooga and then you send it to the places to be assembled for Chicago Museum or anywhere else.
Well, I think one of the main goals for the company is to assist with the construction industry, which is literally still using sticks and beams, columns and beams. It is so old. The construction industry is really in a tough spot, and they need to advance as quickly as possible. If you look at the technology that's in the construction industry now that's starting to pop up, that's what they're focused on, because there are so many inefficiencies in that process. Building on site is inefficient,
Yeah.
because there's already so many accidents and problems on site. You don't want to add to that chaos. So if you look up, prefabrication and modular architecture, you're seeing that designing and building inside of a factory and shipping it at site is where the efficiency lies. That said, there is something beautiful about printing on site, but it's not efficient.
Yeah, it's not efficient. Yeah, that's
No.
good, right? I will just go with some of the questions. Sorry, go ahead. You're saying something?
No. Go ahead.
Going with some of the questions. This comes from Maro. I'm going to go with last name. You know how I will pronounce it. Radinovic. He says, "Hi, John. First of all, thanks for being one of the best professors we had at SCAD." I hope Owen is not listening. We will not tell him that too. I don't want to create that. But he says further, based on structural capabilities, do you see the branch printing method available for the EV industries for chassis development?
Yeah, I think we, as the advanced concept team, we are saying absolutely. There are some really interesting things that we would love to get involved in. I think I think it comes down to material science, right? If we can find the best material to solve the problems and be a metallic replacement, I think there's been some really cool, what do you call them? Garage tech kind of stuff where you're printing the car. I think Locomotors did a really great job with that first car and stuff like that. But the go-to-market, meeting all of the certifications and stuff is going to be extremely difficult, as the whole chassis. I think every car company is using additive manufacturing to develop some really difficult to make parts, but as the chassis and everything, there's some big hurdles to jump through, and it's going to come down to material science.
Yeah.
The technology to create a lightweight, strong structure we could do. It's going to come down to certifiable materials.
Yeah, that makes sense. Another question from Doug, and I think that's our Doug from the first speaker. Awesome work, John. Can this work for bulkheads along a river? Because this aligns with the urban waterways project that he's working on. I think, can you print a mold to pour concrete also into it? So can it be used for the river bulkhead applications, and then instead of foam, adding other aggregates into it?
Yep. Yes and yes, right? So we can change the size of those cells, so we can make sure that the aggregate gets fully encapsulated down into the bottom. So we could probably get up to 6 inches, maybe 5 inches, a big cell. So you could get some pretty big rock and stone and riprap and dirt and all that kind of stuff all down in there if we need to. And it can mimic, a rock terrain if we needed it to.
Yeah,
we've seen some of those cool projects, but we haven't really had the bandwidth to get involved in some of that yet.
And knowing Doug and now knowing you, we can design it so that even visually also it will just blend in the nature, and under the river, if it creates crevices and cracks for other ecosystem elements, insects and critters to come and live and make their nest, that will be an amazing thing to see how it can really be done with all the fundamental tenets of I would say emulating nature as such.
Go
ahead.
I was going to say, and that's what we were hoping was going to happen here, right? When we build these facade panels made out of this stuff, and we were hoping that there's going to be families living all up through this. It's going to be quite the vertical garden.
The vertical gardening is a pretty big kind of a trend. I would say the entire, not just the hydroponics, but the aeroponics also going forward, and this can enable it to a large scale things. Means I think on the passing by you mentioned about. I don't know if it came from you or did it come from the Chicago Museum, but not just adding these elements in the air to lightweight, but even adding plants there to increase the humidity. That's pretty interesting way to look at things, right? You can always go and buy industrial humidifier and add the water content in the vapor, but things like those, we're just curious, did they come from them, or did you and your people eventually came out from your brainstorming things?
No, they knew they needed to increase the humidity there. The site is that 108-year-old roof, and so everything needed to be extremely lightweight. They did not want to build any additional infrastructure in there. So we were the lightweight solution to create this organic vertical floating garden, I guess. Yeah.
I'm a voracious reader and also voracious person that takes and drags my kids to museums. I literally go there every other year, and I love to see the zoo there in the background over there. Museums are still just amazing source of inspiration. Its nature is one, but trying to see how people are presenting that and understanding different facets are always good. There are so many questions coming in, and there are a couple of questions which are necessarily not completely into the world of 3D printing, but I think you being an architect and a designer's designer, I think I can still throw them at you. But it's coming back to specific questions over here, or I would just say comments like Sherry Sabag. Great work, John. This is a great example of the blend of three things: the bird biomimicry, bird bone inspired, the 3D printing, and the last one, if you want to add something more to that, is the blend of biomimicry, 3D printing, and AI, calculating the minimal materials and density and optimize the tensile strengths. This is a unique combination, and you should be proud that you are at the cusp of it. Anything else in the world of AI that you want to tell us?
Well, I mean, we've got some pretty smart people that are trying to integrate it into our into our workflow even more. I think QC is a good one to recognize what we printed and created, so that we don't have to have someone there looking at it. What does having mixed reality, so that you can walk onto the shop floor and you can see where all the prints should be, where they currently are. Where are the heat maps of all the things. It's cool to do that, but if you could have AI doing that all along, and then you could do a lights out factory, right? So then you could walk away and the factory is doing it all on its own. I think that's a great goal. I think right now most of our robots, we do have people that engage with them constantly. They are usually a 3-to-1 ratio at high. When we turn things up to high, we usually can do maybe a 4-6 person sometimes when we don't really want to do that, but that way there's a person watching over everybody. We've got security light curtains around all the robots for safety protocols, because robots only do what they're told until they don't, and then someone gets hurt. And so we are integrating as much AI as they'll allow us to do into this factory. We're trying to do it. We have some really passionate people that are focused in that area.
And talking about passion, I know specifically what you bring to the table, kind of trying to reconnect to another question on the panel. You are in a room literally filled with PhDs, and you are a designer. How does that fit? How are you enjoying that? Are there any barriers still that you have to overcome? Tell us how it feels to be people with. You're also in the room with NASA people and moon exploration. Tell us the role of a design mind over there.
Well, I am the only industrial designer in there. I'm filled with architects, and I was trained as an architect, so I'm well aware of the architecture mindset. And it's very different than an industrial designer's mindset, honestly, which is very different than a engineer's mindset, and even further from a material scientist or an algorithm scientist or a robot wrangler and hardware guy. So
Robot wrangler, I'm going to write that.
Yeah, robot wrangler is that's what I call them.
Kind of the movie, I think, which movie was that? Wrangling and boxing, Real Steel. Where they actually had, there you go, man.
Yeah. It's humbling. Again, this is the smartest group of people I've ever had a chance to work with. But I have not in just one occasion been told that they are very appreciative for the storytelling capabilities of a designer to come in and always embrace the customer needs, always embrace the thread of what is the branch brand through everything that we do, from the way that we answer the phone, the way that we welcome people into the factory, to the way that they touch the product and interact with it. What do they see on the tour? And I think it's that ability to always bring it back to a common goal. I think everybody is so smart that they sometimes myopically solve the problem. And being a designer, you're trained to kind of look at everything. And as you dive deep and come back up and dive deep, sometimes you got to pull people with you. And that's been a really great skill set to always remember where we're headed. So we're not just looking at the stones on the path, that we're always looking at kind of the direction of the stars and following that. And sometimes you listen a hell of a lot more than you talk, and that's okay. But learning so much from those conversations that you just get to be a part of.
That's the humble part of you. You mentioned about reaching out to the stars. Means the slide that you showed about the NASA with the facade of the actual scan of a lunar
Yeah.
landscape. Means isn't that just amazing? Means if you literally put that horizontal and we can actually walk on the moon. Means that's I would literally wherever it is. It's going to be in Chattanooga. It's going to
We
be
can do it.
Huntsville. You can do it.
We can absolutely do it.
It will be nice to just walk on the moon for a few hundred yards and walk on Mars. We have to
Hey,
think
some people think we've already done that, somewhere in the desert that that's where they filmed it from. So we could just go there instead.
Yeah, we can make the flag move. We can instill those things, add some Photoshop stars in the back in the background as such. Yeah, that's pretty interesting. We should get Neil deGrasse Tyson over here also to talk about that. Couple of specific things. I want to keep on talking, and I would love to do that. Peter Kingsfield, shift. I missed that, but I think about shift. You still are trying to do a December shift, right?
We are going to do a digital shift. We're going to do a digital shift. But if you want to know what shift is,
yes, can you please just tell in 1 minute what shift is, so people who are interested and intrigued.
In 1 minute, we used to, back in the day in 2019 and before, we used to do physical events where people would always get together, and we would teach empathy, collaboration skills, refining hard skills, and amplifying storytelling skills. And so, each of our camps have, about 100 people coming together, interacting with thought leaders, which is why GVOC was there, to be inspired and figure out what are they going to do with their life, how are they going to build stuff. All of our camps are hyper local theme. So Story of Making back in 2015, or Beyond the Map was focused on what do you do when you get past the part in your career where you've planned that part out. Like, what do you do then when you're off that map, or your education doesn't align with the career path that you're going on? How do you navigate that ambiguity? Or perspective, understanding your own biases and the way that you view the world is maybe not be the right way to do it. Like, every step from the bottom of the river to the top of the mountain, every step your perspective changes, and it's okay to recognize that the way that you view the world changes, right? That's how we grow, with that growth mindset.
And I'm going to say this again, and before that, not a disclaimer, a disclosure. I sit on the board of Ether Learning also, but guys or girls, this is one of the great experiences ever. I even took my kids over there, and they also learned a lot, and they are still related to the things that learning, which we cannot do it in a school or classroom world. So whenever you have a chance, try to see what I think Shift can do, and knowing Shift and the planners, all three of you, I think when the virtual one should be something completely different than just a normal kind of a virtuality as such. Let's go with one or two more specific questions. I see myself over there.
Yeah, that's you. That's you right there under the rocket.
Saturn V rocket. You are so intelligent, Mr. John. No, that was an amazing element over there. Kind of.
Oh, there you are there. There you are there. Right there.
Oh my God, that's right around Chattanooga. That's the Ruby Falls cave. Oh my! I still might
famous.
Goosebumps over here. The humanizing innovation. One question again from Pierre. What range of plastics can you run in the extruders mounted on the robots? Amorphous and elastomeric only, or semi-crystalline range of those?
Oh boy.
And it's okay. I think if you want, I can connect you with Pierre, and maybe you can have your technical guy talk with him.
I can answer that more through an email. It'd probably be smarter for me to do it that way.
If it's okay with you, both of you, I will connect Pierre to you, John, and I think I should connect you and Doug for that bulkhead project that he's already working on. One more question from Maro, M-A-R-O.
No, Maro, don't you worry.
Oh, you know him. Okay.
Oh yeah.
I think you just need to amp up his workouts now. Owen is going to go after you. He's already giving you love. Do you foresee a change in the race of acceptance, the adoption propensity of this 3D printing in daily processes?
Yeah, it's actually been really difficult to get the construction industry, which is slow to change at all. If there's anything that can accept it and they do it, I think, we're already off to the races. But industrial design, I mean, you can see that the acceptance during COVID when we needed masks and products and stuff. I mean, the community stepped up and showed the value of additive manufacturing. Um, and I think also changing people's perception of plastic. You know, Jivak, you mentioned it earlier, where you said that if plastic's used in the correct manner, it's the perfect material. When you use it for single use, it's inappropriate. Whenever you're using it for something that's supposed to last a long time or have a certain cleanliness level, or something, sterilicity or something like that, I think that that's the important time to use plastics. So when you get the society to adjust to that perception of plastic, I think that's where you're going to really get that. But I mean, additive manufacturing is not just plastic; it's all metals, it's concrete, it's everything. And so we're still in that testing phase. You know, if we can get past this the trough of delusionment, if we get past this trough, right, I think we're going to do really, really well. You know, we've got a bunch of experiments happening with the houses that Icon's done in Austin, and a lot of the stuff that's happening in the Middle East in construction. So I mean, the Middle East, a lot of these countries have requirements by the year 2035. They have to have, like, is it 35% of all buildings have to be additive manufactured. I mean, they're way ahead of the U.S. in their construction trajectory. So it also comes down, it's a lot like education, right? Education can only move as fast as accreditation. And if accreditation is slow, education is going to collapse. It's the same thing with any of this stuff, right? If policy is behind the times, then none of this is going to move forward. So policy and certifications need to change and adapt to societal needs and changes, as well as capabilities and strategies. And I mean, the technology's there. We can already print some pretty incredible stuff, and you know, meet the codes to a certain level. But some of the codes are archaic, and some of them aren't stringent enough. And if they were, our product would be maybe one of the only few that would be a life-saving product. So it's just policy is really important, and so that's another way that design can get involved.
And maybe we are always, I would say, requesting people to suggest some newer topics for our next virtual design conversations. I think the policies, you're touching about the right part, the accreditation, the politics, and what follows what. Behind time, the codes sometimes are not stringent, but sometimes the codes themselves are just like esoteric, like we have to have this make green, like, okay, but does it matter to a small business or a big business? There is a that's where I think the role of design or industrial designers should come and shine also. One more question. I think I think you already answered that. It's from MH. In those are initials. He or she is asking, are you designing more products with composites in lieu of metals? Means, are people coming to you just to displace metal, or is something else that's inspiring them to use your materials?
Our focus is polymers. That's what we do. And our polymers have impressive additives, right? They have carbon fiber, glass fiber, stainless steel fibers, basalt. So, you know, with the product that we printed with the regolith from Mars, that was basalt. And so we printed with basalt fibers. So the additives are what really changes a lot of the properties for us. And I think, you know, the golden ticket would be finding a material that replaces metal for a lot of that. And the basalt fibered polymer that we used in almost every metric did better than aluminum. So we're getting closer. And if you know any amazing material scientists that are looking for some jobs, we may be getting there pretty soon. So we're trying to bulk up that part of our company.
I think not just that, but looking at right now what Branch is doing, I think we will get some plenty of questions in, hey, is John employing? Are you employing any industrial designers or any forward thinkers apart from material people?
Some engineers, project managers, maybe an architect or designer. It doesn't have to be an architect, designer or two. Yeah, probably some marketing. I mean, the whole company's growing pretty well. And in the next few months, we'll know a little bit what that roadmap looks like. But yeah, just go to the website, branch.technology. There's a career page, or you could email, you can email me, john.mccabe at branchtechnology.com.
Awesome. And we will add that email in the chat also. Looking at this on the screen over there, NASA or beyond, means outside of NASA, are there any bigger customers, or basically ideally which industry would you want to work with that you are not working with right now?
Mm. I mean, the toes have dipped into the aerospace, the Air Force, Space Force kind of stuff. We're really trying to get more and more into that, and it's just I am blown away by the innovation that's actually in the government sector. I was throwing it under the bus just until a few months ago, and the Air Force is incredible. Air Force and Space Force, just again humbled by their innovation strategies and stuff. I think that we're a small company and we can't do everything, and that's been one of the hard things. Is that additive manufacturing can solve a ton of problems, but you have to stay away from the shiny and stay focused. And so we're going to stay focused on large scale construction projects, big construction projects. And the smaller team that I'm a part of will be working on these other really smaller advanced concept type projects. So it won't be as much as the business model as some other companies might be focused on.
The next question is from Sandra. I think it's more in the context of pandemics and COVID. How can, with your technology, office buildings, restaurants, other venues can be made more safe for workers and customers? Any insight about what's happening and what you can add to it?
I'm trying to think of one component of safety would be making smart structures or smart materials that can talk to one another. The beautiful thing about a matrix is that the matrix is all connected to everything, and so you could put sensors connected to this matrix and transfer information through it, right? So if this matrix is electrified in any way, right, you could have a low voltage communication system through there. And so then applying sensors to the exterior building facade or sensors to the structure of the building, it becomes a really intelligent communication pipeline for the whole building to kind of talk to one another, all the bits and pieces. And so that way, hopefully you can start anticipating failures or environmental issues or things like that, material breakdowns, things like that.
Hi, I'll jump in for Givak for a second.
Yeah.
Oh, you're there, Givak. Okay.
No, I'm here. My little
I was going
one,
to keep rambling. It was okay. I was going to jump in and start rambling.
No, actually, I should have told you that she just completed her virtual school. It's the schooling itself is still a little bit weird, and she was caught up into her Zoom teachers thing. And it's this amazing world that we are going through right now, and it's perfectly okay. So I did grasp the things about those things. So talking about the mega scale means, so in a way, scale is where you can bring efficiencies. It will not be micro. So you already know where you're going to go with the bigness. The size really matters in what you're doing, right?
Yeah. I think one thing with some of the newer construction initiatives with the massive timber, especially up in the Northwest, those large timbered frame buildings, you have to have lightweight facade systems, right? So as new technologies come in that society is embracing, like the timber, the old technologies that we're using just don't work. And so we're right there to say, hey, you don't have to put these heavy monolithic facades on the outside of buildings. Ours is lightweight. It includes the thermal properties. It has an exterior finish system. It can be intelligent. It can carry a load. It can resist the water. So it does a lot of stuff really, really light, and that's in response. It's what we do, but it's also the industry's accepting it because they are embracing the new structural large timber movement that's happening right now.
Yeah, and timber again means renewability and the forest growth and all those things. That's where this newer, I would say, age of timber, or let's say the bone structure of timber. That's pretty promising.
But it's so weird, the juxtaposition, right? If you have, you're thinking sustainability and large timbers, and then you're not thinking, I'm going to put plastic on the outside of my building now, right? But changing the framework to understanding that you're putting something that's going to last a long time. That's why you're choosing it. It's going to be long lasting. It's also recyclable. It unlocks design freedom. It allows you to create a signature building without creating a bunch of waste. Like a lot of times when companies will build undulating facades, they'll create molds that they then throw away after they do that, right? Our product is the mold. It's a positive mold. And so there is really no waste from the manufacturing of this stuff.
It's pretty interesting. It reminds me, and again, you are an architect. I'm glad. When I was doing my industrial design, we read about an architect. I think he was from Austria. His name, I think, if I'm not mistaken, is Hunderth Wasser, and he proclaimed that the horizontal belongs to the earth, the vertical belongs to the man. So all his buildings, which literally can be extruded from the ground up, the top were always green, and this was around 40, 50 years ago, and everything else would be of materials. But I think what you are proposing in a good way is not just the top. The top hat, yeah, it can still be a live roof, but even the sides can now be back to the nature, or I would say reinforcing the sustainability part of nature.
Could, yeah, absolutely. Yeah.
I can go on and ask a little bit more about the world of building big things or trying to replicate nature and try to integrate that with what you are doing. But I know apart from branch, you are a designer at heart. And there are two questions which are, I think for the designer's mind might not be for branch technology. Let's see, first question from Arjit. How to find a balance between creating only meaningful products and between helping companies financial long-term goals?
I get a lot of questions about career paths and people trying to, one, pay their bills, and two, be passionate about the job that they're doing. And there's almost no job that you're going to love 100% in everything that you have to do. You know, you may be a designer and you get in the flow every day, but you got a crap ton of emails that you have to respond to. And that's just part of the job. And in many ways, you're not going to be able to pick and choose which projects you work on, and you're going to have to find something to be passionate about in each one of them. Where can you make a move and make that project your own? And I think that's those that get the, go through school with the sustainability focus. They're always like, well, where am I going to work? No one's going to hire, a sustainability major. Well, maybe not, but it doesn't mean that you can't make a huge difference. There's all these designers that graduate with a sustainability focus, and none of the job requirements say we are looking for somebody with a sustainability focus. But if you go in and year after year change the amount of material or the amount of waste or where materials source from or how the life cycle of that product from beginning to end, or can it be used to have a second or third life, you're slowly changing the world around you, right? It doesn't have to be a big move. Every project doesn't have to be a massive change. You're incrementally changing the brand, the way that people engage with that brand, the way that they fall in love with the touch, the feel, what happens when I get rid of that product, and I think that you just have to find things that you love about every little thing. And there's going to be things that you just don't like doing. And that's part of it. That's part of being an emotionally intelligent, growth-minded professional. You have to embrace those things and go, I'm learning a lot. I know that I don't like that. I know that I'm a professional, and either leading my team or being a part of a team that's being kind of asked to do something. We're going to band together and we're going to solve this problem. And we don't have to tell leadership that we have reduced plastic in that material by 16% this year. We don't have to tell them that. We know that we have done that. And over time, you're going to add some incredible metrics to your resume, that you can then talk about, when you're looking for your next season of your career.
I like that. And also, thanks for answering that little bit off the topic kind of a question, but you answered it really well. You are an educator yourself. Just looking at the slide that you're sharing right now about your structure, your main component, and then covering it with fabric. We are right now trying to, it's a prospective client, but working with an amazing team. They're I should not say they're former Navy SEALs and Marines, and they have invented a fabric, which is literally just like a denim fabric or something, but it stops a Bowie knife coming at you. It will just stop it going through it. So it's really a strong fabric as such. And I'm just trying to see how if you have your elements and you want to clad it with some fabrics, maybe for a wing of an aerofoil shape or something, I think maybe you and they should talk with each other. So if you're okay, I will try to connect with them and see.
That'd be great.
There might be anything, because it's amazing. They create apparels like this, which will look like fabric, but they will stop a steak knife coming right at you. So I do not know why you would want better. I would want that, but I think for people who are not just in the military or police or fire elements, You might be an NBA player, you might be an pretty top cheese of any company. You would need to have it for your insurance or security. So that's pretty interesting.
Sure.
Almost we are there. I see David is already on the backstage. Maybe one more question I think from David also. It's like for our California friends right now, the fire is still raging. It's a sad thing that's happening. How about the anything from in what you're doing in the fire resistance part of it? You mentioned the R80, but anything
Mhm.
that can help suppress or retard a retardant kind of a thing?
Well, I think that's one of the biggest hurdles for any polymer. It's never going to be able to resist. Well, I can't say never, 'cause you never know. But that's one of the biggest hurdles for architectural certification is fire and smoke. And so that's a lot of our R&D time is focused on mitigating smoke into a room and resisting fire. And so that's why we're really focusing on material science right now, because we've chosen some really great materials and mixed with a fire retardant foam and a fire retardant skin. Structurally, we're fine. We've passed all those codes and certifications, but we know we can do better. And we know that we can use this for structural components, real structural components in the future. But again, it comes down to material. It comes down to the material to save the humans, give them enough time to get out of the building.
Yeah,
What it comes down to.
that's amazing, and I'm just really impressed by the portfolio of what Branch can do in this mega scale printing. And pretty soon, when the travel opens up, we'll like to visit some of the structures which are now across, or maybe at least go to Chicago and see the one in the museum. Once again, John, thanks for your time. Feel free to be on the panel. The next one, David is an amazing speaker, and he will share plenty of his sides too, his insights too. But thank you again, and we will keep in touch.
Yeah, thanks for having me. Appreciate it. Thanks, everybody.
Absolutely. So again, ladies and gentlemen, I hope you are still in line. I see plenty of you are still in, and it was amazing kind of an, I would say, the chapters of this evolving narrative we have today, starting with the world of biomimicry, then we'll go into the world of entrepreneurship, then in the world of literally mega scale building, and now we will be entering the future of mobility as such. But trying to connect back to one of the questions and also what John was mentioning about the right, I think you mentioned a pretty interesting element of the right context of choosing the materials, right? Means plastic sometimes get a pretty bad eye in this single-use straw that of the video that went viral about the small turtle with the straw coming out from the nostril. But plastics can be used in the right context, right? Means I have a kind of an Leatherman multi-utility tool, completely stainless steel. It's going to last for 100, 150, 200 years, and that's the promise. But over here, I have plastic. It's Lego bricks and blocks. It's still plastic. This is also going to last maybe longer than that because I used to play with Legos when I was back in India. I still got my bucket full of them, emptied them in the bucket of my kiddo, and we are still using it. So the context, the design, the usability element of it, the way it's going to be used or misused in context too, really matters rather than just blaming somebody in isolation, right? Just as when we say design cannot be done, or good design can never be done in isolation, the same thing about material choice, understanding where it's going to be, how it is going to be used, the user scenarios, the evolving, I would say, nature around it, and then designing with this or that. So I think going where John is taking a branch technology into regions beyond, right? Not even the terra firma, trying to do the terra firma for other planets and satellites. That will be pretty interesting to see the work of an industrial designer directly going to the outer space. I'm all for it. I have my rocket ready to lift off anytime.